Hi, I'm Troy.
I'm Effie.
I'm Meredith.
I'm Daniel.
And we'll be talking about desalination of seawater through reverse osmosis.
Throughout the world, there is a growing water crisis in places like the Middle East, where they lack fresh water sources, as well as places like California, where they're going through a 4-year drought. There's a need for access to fresh water. As this chart indicates, some of the most populated places in the world have the highest level of water stress. And there's very little fresh water on Earth, and most of that is trapped in glaciers and ice caps. However, 96% of the world's water is located in the oceans, which is an expansive, untapped resource that through desalination can solve the world's water crisis. Desalination is a process which converts seawater into fresh water. The world already has a pretty large dependency on desalination, and therefore it's most important to make it the most efficient and effective method as possible. There are a few types of desalination. First, there's multi-stage flash, or MSF. Then multi-effect distillation, or MED. There's also vapor compression, or VC, electrodialysis, or ED, and lastly, reverse osmosis, or RO. The most popular in the past has been MSF, which is a process that separates seawater into steam and salt through flash chambers, but through improvements to technology, RO has actually become the more preferred method. And it's a method that applies pressure to seawater through a membrane that's permeable only to water molecules.
So desalination of water using reverse osmosis is generally a 4-step process. First, the ocean water comes in from an intake stream, and then the water becomes pre-treated in order to have a higher water quality before going into the reverse osmosis system. And then after going out of the reverse osmosis system, the pure water is treated so that the water is suitable for drinking around the country. So the inlet stream takes water from either the surface level of the body of water or under the surface level of the body of water using wells or seabed filters. The subsurface level intake streams are generally more favorable because the sediment underground can separate some of the organic material and the large waste products inside of the water to ease the treatment process before entering the reverse osmosis membrane. So after the water is in the plant, the water becomes pre-treated with chemicals in order to avoid biological fouling and scaling on the reverse osmosis membrane. And biological fouling is the buildup of organic material and living organisms in the reverse osmosis membrane. And then scaling is the buildup of salts, such as calcium-based salts, that could build up on the reverse osmosis membrane. And both can damage or harm the membrane and reduce the efficiency of the process. So 2 methods of pre-treatment is the conventional process or the ultrafiltration process. And the conventional process feeds in the water, and the water goes through a unit that coagulates and fluctuates the living organisms and organic matter in the water and solidifies them so that they can be easily filtered out through the multimedia filter. And then the water goes in through a cartridge filter, which usually has a mesh size of about 5 to 10 microns to filter out any other smaller particles that the multimedia filter did not extract. And then the other method is ultrafiltration, where it reduces pretreatment down to 1 unit using the Z-weed, using ultrafiltration membranes such as the Z-weed, and it's generally more efficient than using the conventional method because it reduces biological fouling and is more environmentally friendly. So the reverse osmosis system, before the water enters the reverse osmosis membrane, the system will add cleaning chemicals such as the ones displayed above, and this will further purify the water in order to reduce biological fouling and scaling. And then after the water goes through the reverse osmosis membrane, the pure water will go through the permeate stream and then the brine and the chemicals will go through the concentrate stream. Afterwards, the permeate stream will undergo some post-treatment before it's sent to households. So acids and bases will be added to adjust the pH level to about 6.8 and 8.1, and then liming materials and carbon dioxide will be used to remineralize the water to add things such as calcium and fluoride, and then ultraviolet rays will be used to disinfect the water from bacteria, and then boron selective resins will be used to remove the boron from the water. And then the water will be sent out to households worldwide. In order to remove brine in an environmentally safe way, there are three methods. One is deep well injection, which is pictured over there, where the water is sent to a well that is isolated from any water lines or the ocean, and then, or the waste can be sent to evaporation ponds where the water will be evaporated, and then wastewater treatment plants can be used to just dispose of the wastewater in a friendly manner.
Before we talk about our reverse osmosis and multi-stage flash efficiencies, we're going to take a quick break. You get it? Here we're going to be comparing the energy efficiencies of multi-stage flash and reverse osmosis. Multiple effect distillation has very similar results to multi-stage flash because of the similar processes. It's very evident that reverse osmosis is a much more energy efficient process because it has a much lower electrical energy consumption per meter cubed of seawater and a much higher potential energy recovery. Daily desalination production amounts to about 10 to 13 billion gallons of water every day. Despite how large this number is, this still only accounts for 0.2% of the world's daily water usage. Up until recently, multi-stage flash has been the primary source of desalination, but now it's about 60% reverse osmosis. The graphic here shows how large a million gallons is, so a billion gallons would be 1,000 times that. If we're comparing a specific multi-stage flash and reverse osmosis plant, these are both located in Saudi Arabia. The daily water production is slightly higher with the multi-stage flash, but the reverse osmosis plant has utilizes about half as much of the electrical energy per cubic meter of seawater. Well, another thing to compare is the durability and longevity. Multi-stage flash and multiple effect distillation work really well when treating highly saline waters such as seawater. They're very robust and can last for many years. Reverse osmosis, on the other hand, is much better when treating brackwater, which is a combination of seawater and freshwater. This is because of the membranes in a reverse osmosis plant. They can only last generally for 2 to 3 years, and this lifespan can be affected either by the water quality. A better quality of water leads to a longer lifespan, level of pretreatment. Higher level of pretreatment leads to a higher lifespan, and the operation conditions. If the RO membrane is operated within a specific temperature and pressure, it is more likely to last longer than if it is to be operated outside its bounds. Another thing to consider is the environmental effects. A study was conducted in Bahrain to test the effect of multi-stage flash and reverse osmosis on the surrounding marine ecosystems. Multi-stage flash accounted for the majority of the daily water production, but it also resulted in almost all of the effluent production, which is any type of excess material that is left out because of the process. And because of this, there was a significant increase in the temperature and the salinity of the surrounding waters, which had a reduction in the biodiversity and abundance of the marine ecosystem. Reverse osmosis, on the other hand, had very little effluent production, and as a result, temperature, salinity, biodiversity, and abundance did not change.
Membrane distillation. Membrane distillation is locally available and tough to treat water. And here are examples of everyday use of reverse osmosis. Also, we're going to compare reverse osmosis to MED and MSF. Reverse osmosis uses low pressure, and it is high water recovery and high rejection, versus MED and MSF, where they use more pressure because they're using more of the heat consumption from electricity, and as you can see, it also uses less vapor space, low material cost, and can be scaled down. Also, there are visiting challenges while using membrane distillation, as far as membrane fouling and scaling and loss of hydrophobicity. Here we're having a chart of reverse osmosis and the cost between brackish water and seawater. And as you can see, seawater costs a little more than brackish water because it has a lot more salt content in it, and it will take a little more to take out most of that salt content. So, but it also shows that with more capacity, that the cost still goes down between seawater and brackish water. Here there's a chart of energy input between reverse osmosis, MSF, and MED. And as you can see, reverse osmosis is still cost less compared to MSF and MED. And that's because reverse osmosis uses most of its own energy compared to MSF and MED, which uses energy or heat from electricity, which costs more and when you're investing on them. And here we're going to talk about why you should invest in reverse osmosis compared to MSF and MED in the long run, because you have to take into consideration all the costs, including the land cost, construction cost, insurance cost, technology, where you're going to use your technology, and how much chemicals does a place have and what you have to get rid of. And as you can see with reverse osmosis, it costs less compared to MSF and MED, and that makes it easier and more favorable to use reverse osmosis than to use MSF and MED.
Reverse osmosis is rapidly becoming the most efficient method for desalination. Costs for RO are much lower than that of MSF or MED and are projected to go down as technology improves. RO plants are more energy efficient, which compensates for the slightly lower production rate when compared to MSF. Though RO is an excellent solution to the growing need for freshwater sources, there are still many improvements to be made. Ultrafiltration reduces the use of chemicals and biofouling, but requires a lot more maintenance and at higher costs. Membranes need to have longer lifespans with greater durability, while minimizing the use of chemicals and waste and lessening the impact on the environment, all while keeping costs down. RO is a better method for desalination, and with projected improvements, RO can become an institution around the world and be a solution to the desperate need for fresh water.